All right, welcome back to the Ceph Developer Monthly, everyone. I've added it to a few calendars now, so hopefully it will be a bit more pervasive and easy to remember for everyone. If you have not yet added blueprints, even if it's just a single comment, please do so to the page so we have a record of even after we discuss things. Otherwise, I think this should be relatively short. So, Sage, I guess we might as well start with your allocator accounting, and we'll go nuts.
Yep. Okay. So we don't have a whole lot, except that there's a discussion we kicked off on the list a couple days ago about doing allocator accounting, so we can tell how many of each type of object are being allocated for doing cache, back pressure, stuff like that. We had a discussion. Alan went off and implemented it. His proposal. He just pushed a working version of the branch this morning or last night. I just rebased it and cleaned it up a bit and pushed a pull request, which is I will put it in the Etherpad. And I've run the unit test and it works. So that's as far as I've gotten so far. But the short version basically is that find the code in each class that you're gonna put into a memory pool. You do something like this. An Etherpad. You just call a macro, and that basically declares the new and delete operators, so that when you allocate or deallocate that object, it'll put it in the right memory pool. And then somewhere in a .cc file, you actually declare, you implement those operators because they're not done inline. And let's find that. Hold on, where's that code? Looks like somewhere else. And the implementation there is pretty straightforward if you look at the macro. The number of pool does this, and the define in mempool does this. Basically implements them. Probably drop that assert here just for performance because this is a hot path, and it calls the appropriate factory thing. And then you basically declare the mempools that are you want to exist somewhere else. I can't remember what the macro looks like. That's here at the top. Let's see. And the interesting thing is that it creates a namespace for. I'm looking at the header file. It creates a namespace for each memory pool, and it declares all the common container types, versions of that in that namespace that are automatically set up to allocate in that namespace. So I can change my standard map to be my namespace map or my mempool map, and it will, all the internal allocations there will go in that mempool. So that makes it pretty easy to use. It's based on he took the code that he did for the slab allocator container stuff and rejiggered it to do this. Normally it'll just, it has like a minimal amount of accounting for the pool. You can ask it how many bytes have been allocated in that pool, and that's mostly it, I think. But there's also a debug mode that you can enable with the compiler define whatever macro definition that will also count how many of each type of object are allocated in that pool. So our debug builds can have a whole bunch more instrumentation. We can figure out, the cache is 2 gigabytes, exactly how much of that is consumed by every different type, which sounds pretty cool. So I think the next step is to actually convert a bunch of types over to use this, and then do some profiling and make sure it doesn't have any overhead that's going to kill us. But this I think satisfies everything that I wanted. I was a little bit worried because I thought we were seeing a whole bunch of heap fragmentation the other day, and that probably we would want to not just, this just passes through to a regular allocator once it actually does the allocation. It does the accounting and then allocates with whatever your allocator is. I was thinking that we wanted to set up pools or slabs or whatever for all the different types so that they would pack more efficiently in memory. But once we actually looked at the types that we were allocating, the heap size actually looked pretty accurate. So I think actually we're not fragmenting that bad. But we might, maybe in the future we want to change that. I'm not sure. Anyway, that's it so far. Any comments, questions, concerns about this path? Yep.
One, can we use this to specify a maximum amount of memory we want for the O-node cache rather than having users specify the number of O-nodes?
Yep, that's basically the point.
Yep.
The mempool won't have a max, but the BlueStore or whatever will periodically go and look how much memory is being used in this memory pool, and they'll say, oh, we're close to or above our threshold. I'm going to exert some memory pressure and start trimming some stuff. This is how all the memory management in the kernel works. It's how how it needs to work. Otherwise, it's very difficult to tune all this stuff. So that's the big takeaway here. So we'll definitely need it in BlueStore, but I think it's also going to be really useful in even just for instrumentation profiling purposes in the OSD. So during recovery, for example, when there's lots of memory, we're like, where is this memory coming from? We'll actually be able to look and see. It might be that we could dynamically do our PG log trimming based on how much memory we're consuming, or I don't know, whatever. All these things become possible.
Your comment about fragmentation too, I think that's still good. I mean, especially with all these linked list structures that we have, right? We've got pointers going potentially like everywhere, all over the place.
Yeah. Well, I think it's going to be. I mean, in theory, if the allocator is doing a good job, then fragmentation will be minimized. I think if it turns out that it's not doing a good job, then we can revisit that. It was a problem a long time ago in the MDS, and we switched to boost pools, and it got a lot better. But that was like years and years ago. I don't remember how long ago it was. So it might be that it doesn't. I'm guessing that it's better now than it was. And that spreadsheet that you looked at was estimating like 500 bytes per blob and per extent. And when I went and added up the actual size of the struct, it was like within 5%. So,
sure.
So I think we're in pretty good shape there. But we can come back to that if we need to. Yeah. Okay. Any other comments, questions, concerns on this?
Yeah, it seems like a good idea. There's the other intersecting information I have is that relates to similar types of techniques that might be necessary to interact with things, an EBR or QSBR strategy, lock-free strategies, and I don't think that. And I think that's heading in the same direction, convergent direction, even though it's complexity. I don't understand how they converge, but they probably do.
Yeah. Yeah, I mean, I think that the big question, I think, is this wrapper around the allocator going to have some sort of overhead? And that's because it might. The statistics are shared, so there could be some contention there. To mitigate that, it's just sprayed across a vector of like tens of slots based on your thread ID, hoping that it's not going to ping pong between cores too much. But like, who knows?
Yeah, I was familiar with that. There's someone wants to look at it for comparison. There's the MCAS system has a generational allocator that has some similar properties. and additionally has support for, because it's generational, has support for constructing algorithms that prove that that all access is to an object, where in the generation that all accesses, all threads that may have seen this object have proceeded to a new epoch, and therefore we can GC other ones and things like that. But in most respects, it sounds similar to me. It's a thing we were experimenting with in some code bases, but we don't have any work in progress to do things with it right now.
Yeah. I think the only other thing that might be concerning is it's built on the same slab allocator that he was using for the inline slab container types, and so when it does allocate memory, it's allocating it in chunks, and then hoping to reduce contention on the allocator itself. So I'm not certain that we want that in this case. Like we might just want the accounting and then push everything off to the low level allocator, but I don't know. Unfortunately, when I've been doing perf profiles on my machine, it's like none of the allocation stuff is really showing up on my plots. I don't know why that's the case. So I don't know that I can really measure the impact of this in my.
Well, if the slabs aren't too unreasonably large, they're probably a good idea. Would be my intuition.
Yeah, there's going to be some walking overhead related to the slab allocation stuff, and I don't want to. I imagine that the locking is going to be more sophisticated in the generic allocators with RCU type data structures and so on.
That's an interesting point. Yeah,
all that stuff.
Yep, that's fair. That's a fair point.
But we'll see. I have another box that's slower. Maybe the profile will be more meaningful there.
I mean, the challenge is that while that statement is true, they're not presenting right now. The interface. I'm not familiar with very many allocators that present an interface for this type of usage.
Yeah, definitely not. Although actually, that reminds me. I think there was something in some of them that let you set up separate. Well, I'll have to go Google that because I thought there was actually something. Maybe it was J.E. Malik had a full concept. Remember. But anyway. Yeah, I was surprised when I looked at like boost pool that there wasn't a like how big is it type query, which was sort of annoying.
Maybe they're waiting for you to edit Sage.
Yeah, maybe. Okay. Well, that's all I had up there. Any other questions, concerns, or anything?
With things like extents and BlueStore, would it be worth doing a bunch of upfront allocations of those, since they're probably going to grow to a certain extent anyway?
Maybe. I don't know. I don't know. Maybe. Again, I think the generic allocators are going to have much more sophisticated locking and better performance tuned fast paths, hot paths, or whatever, than even something that we put together that's special casing it. But it's unclear. Maybe the slab stuff that this is implementing will help, but we'll have to benchmark it and see.
So this mempool is mainly improve the performance of short-allowed data, not long-allowed. Is it true? Because for long-allowed structure, I guess multi-thread like thread catch, like tcmalloc or jmalloc may matter for this.
That's a good question. I'm not really sure. I think most of if you ignore the slab piece, the idea is that we just are passing through the actual allocations to the underlying allocator, so it shouldn't change. But I notice it also is allocating them in slabs. So I would expect it to be the same as the allocator, except that the slabs will sort of extend the lifetime of those allocations somewhat, so that things that are allocated close together will be stuck in the same slab, and if you deallocate one but not the other, it's going to be pinned. But I don't really know. I don't know. It's probably pretty complicated behavior. So we'll see. It's probably, I think you can also, it would be nice actually if we could just disable the slab piece and make it or a slab size of 1 and have it go away. But I'll check in with Alan about that. It might be you could just see both ways.
So back to the original goal. I think Alan's proposal for this PER is mainly to solve which problem? Is
I mean, my goal is just the accounting. That's the main thing I'm worried about. I want to be able to put like 10 different data types and all the containers that use them in a pool, so I can say how much total memory is allocated by all of these things, and put memory pressure on the cache based on that. So yeah. That's what I want to do. I think that Alan is. I think he's also trying to just reduce allocations with the slab thing at the same time. And I'm not certain whether that's going to be a good idea or not. But maybe.
Yes,
we'll
yes. If only a very small set structure, I think this way may be too complex to solve this problem. Yeah.
Yeah.
Maybe we only introduce a very simple fixed size structure to solve the very small vector or very small map problem. Yeah. Yes, I think this is maybe. I hope it may be too hard to make it perfect.
You're saying trying to solve both problems at once, you mean?
Yeah, I maybe introduce the whole thing. Yeah.
Okay. Yep. I'll talk to him. He couldn't make it, unfortunately.
Yes, if you want to build a very custom memory allocation, maybe it's a good way. But it's a whole thing, I think. But if you only want to solve a very small thing, I think it's too big.
Yeah. Makes sense. Okay. I think I agree.
I do see calls to new showing up in the perf profiles of BlueStore that I've been doing. I mean, it's not huge, but it's not insubstantial either.
Is it like 1%, 5%?
Like 5%, 4 to 5%.
Okay. Yeah, I've never seen it more than like 1.5. Just sort of. Yeah. I don't know. Oh, I'll try it again. Yep. Okay. That's all I had there. I guess the only other topic is the boost stuff is basically ready to merge as soon as we get the tests going again, and the slab containers also are ready to merge. That are mostly, they're also using a variation of the slab allocator, but they allow you to specify that some number of those slots are inline as part of the container. So when you have only a few elements, then you don't do any additional allocations. So I think once both of those merge, we need to go through and figure out where we want to use them. Because there are like probably a bazillion opportunities where if we'll just spend more memory on the stack, say, or somewhere where it doesn't matter that much, and we'll avoid hitting the allocator at all. So the slab containers have like list and map and all that stuff, and then Boost has small vector, and it also has flat map. Although I think flat map doesn't have an inline, so it's still an allocation, but it puts all the keys in like one allocation. So I think just be aware that that's coming. I do have a pull request that tried changing buffer list, the list of pointers in buffer list, to be a slab list with 3 pre-allocated slots. And it makes my it makes the unit tests for buffer list run like 3% faster. But when I tried I did a 4K random write workload, it wasn't noticeable. I couldn't see any difference.
Yeah, if it's only a little improvement, I think it's not worth to change now. Maybe, yes, it uses a very simple unit test.
Yeah. Yeah, it's. I mean, I think the problem with all of these is that it's there isn't going to be any single container where switching one container over to use the inline types is going to make a significant difference. But if we changed all of them, then it would probably be significant. But that's a lot of work, so it's hard to tell up front whether it's going to be worthwhile to change all of them or not. Yeah, we might need to go through and carefully look at a profile to find the top 20 or something that come up and change all of those, and then see if we can see an impact. Or again, I think we need good, high quality profile runs to guide that.
Yeah, I saw some benchmarking about flat map, and it was very workload specific, but it has very different fill properties, and if your workload is right, it was really beating other maps. But if you fill it wrong or search it, it's reversed.
Yep. Yeah, exactly. Yep. Okay. That's all I have.
There were a couple of late additions here. We have Nitin for the adding iSCSI inquiry interface to RBD devices, and Josh with a QoS update. So I guess we'll start with the SCSI inquiry interface to RBD. Nitin, are you on and mic'd?
Yes, can you hear me?
Yes.
Yeah, just this is the first time I'm attending the Ceph monthly call, so I'm not sure what is the overall goal of this meeting, but I thought I can add this because we would like to see this in the RBD interface. And so if there's any update or anything we can discuss, I mean, most of the stuff is captured in the mailing list and also on the tracker, which is listed on the wiki page. So I don't know if there's any update because I haven't heard anything, or is there any plan to include it in a particular release or any?
So yeah, I mean, that's basically, you can treat that as it's like a backlog item of a nice to have, and we have no active plan to incorporate it now. But contributions are welcome. But yeah, right now there's no one actively working on it.
I see. So this would go in the kernel soup.
Well, so it's half of it. All the preliminary stuff needs to go into librd, because it would be responsible for when an image is created or a snapshot is created, that it would generate all those unique IDs that would be stored with the image permanently. But yeah, and then after that, back support is in, including all the changes that are necessary, even on the OSD side with the RBD class methods. Then the kernel would get updated to be able to then query the OSDs for that data, and then if it exists, and be able to then map it down, at the KRBD level, and then someone else would have to plumb it in, at the SCSI level or wherever, however else it needs to get plumbed in.
Okay, so thanks for the update. I think, yeah, we'll see how to take it from here further. But if there's any update, means that's what I was looking for, and seems like there's not much update right now, and there's no plan, so it's just a nice to have feature so far.
Yeah, so far we're treating it as a nice to have, as opposed to a capability blocker or something like that is blocking other efforts.
Okay, thanks for the update. So yeah, I'm done from my side then.
Oh, okay. I take myself off mute. That works better. Josh, you want to give the QoS update?
Sure. So basically for QoS, we've been working on this for a little while now. We're trying to add in support for using the DM clock algorithm to be able to eventually have quality of service like reservations among different clients. But to start off with, we're just focusing on getting the algorithm correct. And Eric Ivancic, who's on the call now, has been implementing that and working with some other folks from South Korea Telecom and CTE to fix some bugs and get that working correctly. And now it seems to all be passing the radar suites.
We lost your voice.
Between, shoot. Is my mic back? Or is it gone again?
Yes.
All right, thanks.
Yeah, you're good now.
Sorry, my headset comes in and out sometimes. So the initial version that Eric's been working on is just trying to distinguish between background I/O in the cluster, like recovery, scrub, and snap trimming, versus client I/O, since that's been a problem for users in the past. So that branch that Eric has been undergoing a bunch of performance testing lately, and I think we should have some results to share soon. Eric, do you want to add anything to that?
Not really. So I've been running it in various ways and generating some graphs, so I'll share those relatively soon now.
All right, cool. That's
Can I?
If anyone has any questions, we'd be happy to talk more about that, what we're doing.
Yes, this is Nitin again. We would like to have quality of service, like guarantees if we can provide, like if you're especially in the Ceph environment, if there are different services are using the same cluster, like a RBD use case versus CephFS and REDOS and all that. Is there a way, this is what we would like to see if we can provide a quality of service to a particular service, so that if something goes bad, that service gets least impacted and we have like priority of services. Is that what you're trying to do? I don't know much about it, and I would like to get more information, or if there's a page or any design document or something. Would like to know more about this.
Yeah, I think that there are some past pages from past CDMs that with some design documents. But the idea is that eventually you'd be able to assign different kinds of like reservations to different kinds of clients. So you might have, you could assign like all your RBD clients the same, perhaps internal client reservation, and all your RADOS clients some other one, and all your CephFS clients different reservation, so they are guaranteed a certain level of service and get some proportional share based on what's available after that point. But it's still a fair ways away from being implemented so far. But that's the plan now to get there.
Is there a target release? Just curious.
Not precisely. Hopefully the more limited form with the distinction between background I/O and client I/O will get into Luminous. But I think the client side distinctions are further off, since it requires a bit more work on the configuration side and user kind of management of the different limits.
Okay, so yeah, I would like to get details. If maybe offline you can send me some links or whatever to understand what's the effort going on.
Yeah, I can find the link to a previous to that and put it on the wiki page there.
Okay, thank you.
All right, that's it. I think that was probably the shortest Ceph developer update on record. So awesome, 30 minutes and give you some time back to your day. So, all right. Well, thank you everybody for coming. The next planning session will be on November 2nd. That will be our APAC friendly time, so 9 p.m. Eastern. Please, I'm going to be pushing a lot harder to get some blueprint discussions on the wiki beforehand. I want to make sure we're making good use of everyone's time for a meeting like this. If you have thoughts one way or the other, if it's not useful, we can discontinue it and figure out a better way. But if we are going to do it, I want to make sure we do it correctly. So if you have any questions, hit me on the list or directly, and I'm happy to answer questions. Otherwise, we'll see you on November 2nd or on IRC. Thanks, everybody.